my capstone, if you don't know anything about me, I'm Christian Sorensen. I'm a future unemployed computer science student. I have taken CCIC courses in cybersecurity, AI, data management, and CompSci. For this project, I play Warhammer, which is a tabletop game where you play 20 to 40 models against each other across a board. And it's pretty expensive, $45 for just one model. So I decided to make a 3D printer.
Oh, there you go.
So I'm going to make a 3D printer. My expert advisor is my dad, Harry Sorensen. He has a full-time job. He also has, he might spend money on this project. Also helping with buying components exclusively from China and other sketchy websites. I have Charlie Hensley. He helped me with a lot of CAD and just talking out. George Maurice, he helped me with soldering and a bit of code that I had help with. Harry Sorensen, he drove me to school and just got everything I need into the school. So I decided to, first of all, pick which type of 3D printer I want. It's either a resin or a filament 3D printer. With filaments, there is some benefits like it being generally faster, cheaper, and easier to use. But with resin, I could get more detail on my models, which would be good for painting them. So I decided a resin 3D printer. Now there's three main types of 3D printing for resin. There's the DLP printers, which use a laser, which is what you normally think about when you think of resin printing. There's the MSLA, which uses a masked screen to shed a UV light on certain parts of the resin. And the SLA, which is just a projector that projects UV light onto the resin. Parts I decided to go with the MSLA because it's just generally cheaper than all the others, and it's easier to make. For the parts I need, I separated into two different parts, electrical and mechanical. For the electrical, I needed motherboard, the screen, the LCD array, and the motor to move up the bed. For the physical, I needed a lead screw to physically move up the thing, the resin printing bed so that my parts can print on it, just a chassis for it to hold everything, and a resin tank to hold the resin. Physical parts for the chassis, I decided to use a normal T-slot aluminum pipe, aluminum rod, which ended up leading to a 34 by 40 and with a height of 44 centimeters that can be seen here. And then to hold all electronics, I decided to cut sheet metal, which probably wasn't a good decision because sheet metal is really expensive with $50 for 1.5 feet by 1.5 feet, which I cut out to fit the parts in between here, to fit right here. For physical parts, a lead screw was best for it, as it lets friction and gravity, when it rotates, it lets friction and gravity carry the bed. Other parts I needed was a 3D printer bed, which I just stole from another 3D printer that was broken, and I didn't have time to do it. And the resin tank, I didn't want to deal with any leaking resin or getting any of the leaking resin, so I decided to buy one off Amazon. It's right there, and it's right here. For a controller board, I used a Raspberry Pi and a Nano DLP one. Nano DLP is a special controller board for 3D printers. It's most of the time used to control a already resin 3D printer, but it can be upgraded on a Raspberry Pi for full control of the 3D printer. It supplies power to both the LED array motor, and it comes with a touchscreen, which I thought was useful. The screen is a sketchy Chinese one, which is an 8-inch by 5-inch 2K resolution screen. It needs to be a specialized screen, or else it could cause burn on the screen, and there's no backlight, which I needed for the LCD array. LCD array is what cures the resin. It's normally a UV light between 405 and 410 nanometers, and on Alibaba, they went from $90 for a small 4-inch by 5-inch one to to $3,000 for the size I want, which is the screen size of 9.5 by 5. So I decided to make my own. Right here's the electrical design. I decided to split up the 3 volts, half watt LCDs into an array of 4 parallel and 10 series. This led up to a voltage calculation of 12 volts and 5 amps. Another thing I learned is 3D modeling. I didn't end up using this, as for some reason my friend's 3D printer failed every single time I wanted it to work. Most of it was to connect the bed to the linear rail and then the tank to the screen, which I just ended up super gluing. Other skills I learned, cut sheet metal, to solder electronics together, and to reboot PyOS, which corrupted. How it went? Not well. So for this, a lot of things ended up failing in the last 2 weeks, including corrupting the OS. So I accidentally messed with one of the components when power was on and it ended up corrupting it. Then I broke the LCD array by short-circuiting it on the sheet metal. So I just laid on the sheet metal and it short-circuited, frying around 40 of my 60 LEDs, maybe more. Goals for this project. I wanted to stay on task throughout most of the time, and I think I did. I barely spent any time because I had so much to do for this project. I learned how to do electric components with the LCD array. I didn't really advance my knowledge of coding, especially with more electronic components. I wasn't able to make the operating system, and I did not make a frame to contain resin safely, as I didn't want to do that. My original timeline was way more coding based, so I wanted to code my OS for the thing. I wanted to code it pretty much how it works with everything, which didn't work out because coding is hard, and I had to sort through a lot of Chinese parts. That's about it. Thank you. Any questions?
Questions? None? That it? All right. Thank you.